どうも、勝手に電力2.0で見始めたいと思います。今日1216回目というところで、このインドネシアの PV ポテンシャルっていうところで、特に東の方のエリアの、スンバ島だとかいろんなところがですね、結構ポテンシャルがあったりするので、そのあたりについて少し話をしたいなと思ってますと。で、実際にこれっていうのが、ISHR、シンクタンクみたいなところですね。これがこのビヨンド2207ギガワット、Unleashing Indonesia Social Potential ということで、これでやっていて、これがインドネシアの太陽光の潜在能力について詳細な評価を提供する報告書で、従来の公式の推定値を大幅に見直しているということですね。太陽光の技術的潜在能力の評価と、この報告書では、国内外でのデータを用いて、インドネシア全国の太陽光 PV の技術的潜在能力に対する地理的空間的評価を行った。インドネシアの太陽光 PV の技術的潜在能力は、土地利用の除外シナリオに応じて3396ギガワットから19835ギガワットの範囲であることが分かったと。これすごいですね。これ多分ちょっと間違ってるかもしれない。発電可能性については、4705から26,791テラワットアワー年を達成することができれば、これは総陸地の4.34%が24.43%を利用することによると。この潜在能力は現在の国の推定値207ギガワットより大幅に高いと。16ギガから95倍っていうとですね。ケーススタディで、報告書にはスンバ島の電力システムの分析などケーススタディが含まれている。例えば、スンバ島は太陽光の開発に高い潜在能力を持っているスンバ島太陽光イニシアティブなどのイニシアティブは2035年まで大規模太陽光目標の13.5ギガのうち2ギガワットを目指していると。で、結論ですね。調査結果はインドネシア政府に太陽光発電の開発のためのより詳細な潜在能力を反映するよう全国の太陽光技術潜在能力の通知を更新する必要があると。で、県レベルでの有望な太陽光発電所の場所の特定を県政府と地域事務所と協力して行うことを提案と。報告書はまた、市軍やそれ以下の特定の場所でさらなる技術的評価を行うことを推奨と。で、報告書、インドネシアが再生可能エネルギー、特に太陽光エネルギーのフロンティア市場であることを強調。高い技術的潜在能力にもかかわらず、政策不一致、魅力的なタリフやインセンティブの欠如、グリッドの寿命の懸念などの要因により、インドネシアの太陽光発電は1%未満っていうので、ダントツ低いですね。インドネシアの太陽光の加速された展開をサポートし、国の再生可能エネルギーの目標と、将来の電力需要に貢献することを目指しているということですね。Exit summary. Seeing the need for an update for solar power technical potential in Indonesia, the Institute for Essential Service Reform (ISESR), with technical support from the Global Environment Institute (GEI), conducted a nationwide geographic information system-based solar photovoltaics technical potential assessment in the country. Technical potential estimates represent the achievable electricity generation potential kilowatt hours, including its capacity potential gigawatt peak, and suitable land area, given the topographical and land use containers, as well as PV system performance. Technical potential is different with economic or market potential as it does not consider projected costs and policy and regulatory limits, and thus do not represent the level of generation that might actually be deployed, but rather an upper boundary estimate of development potential using publicly available GIS data. This report covers both national and provincial level results of Indonesia's spatial analysis and focus on large-scale, utility-scale, ground-mount solar PV application. The analysis of this report is the first step of the series of activities to assess potential solar PV projects in Indonesia and provide an overview of national solar power potential before zooming in to the potential regions. The estimation of the technical potential starts with first assessing the suitable area and for solar PV development. Then, by considering solar resources potential in the area and taking some technology-specific assumptions, the technical potential can be calculated. Several constraints to determine the suitable areas include certain terrain features, protected areas, land use, restriction, water bodies, and others. Table ES1 presents solar PV technical potential in Indonesia given several land use restriction scenarios. Scenario 1, based exclusion plus slope exclusion. Based on the first of the assessment, Indonesia's solar PV technical potential range between 16 to 95 times larger compared to the current national estimates by the Ministry of Energy and Mineral Resources. The amount that is 207 gigawatt. As the assessment goes in provincial and cities legislative level, the finding can be used to inform policymakers, PNN, business players, and other relevant stakeholders to accelerate solar development in Indonesia, starting by updating Indonesia's solar potential figure and identifying potential solar projects across the country. Case study in Sumba Island. Sumba is located in South Nusa Tenggara Timur province. Being an isolated island, Sumba's power system is dominated by the diesel generator, 9 units total 11 megawatt, and several renewable-based power generation such as microhydro, 4 unit totaling 3 megawatt, and solar power plant 1 megawatt, according to the latest loop tour, PNN 2019. Electricity demand in Eastern Nusa Tenggara is primarily dominated by the residential segment, 60%, then followed by business customer group, 24%, public, 11%, which includes public hospital and schools and industrial user 4% in 2018. According to PNN's Eruptor 2019 to 2028, according to PNN Eruptor, it has shown an estimated average electricity demand growth of 7% between 2015 to 2018, and is projected to grow at 8.8% over the next 10 years. Specific to Sumber system in the 2019 Eruptor PNN indicates their plan to add the total of 16 megawatts of biomass power plants, a total of 20 megawatts gas engine power plants, a total of 8.6 megawatts of microhydro power plants, and 3.8 megawatts of solar wind power plants over the next 10 years. More recently, however, the government has occasionally stated their interest in developing large-scale solar farms in Sumba, often dubbed as Sumba Solar Farm Initiative, Sumba Lambing Surya, with a 2 gigawatt target out of the 3 13.5 gigawatts large-scale solar target by 2035. The governor of the Eastern Nusa Tenggara has also shown support for this initiative, noting that the island will be center for solar PV development with up to 20 gigawatts of potential. The initiative is expected to deliver electricity not only across the Eastern Nusa Tenggara but also to Bali, Java, and other load center using high voltage direct current HVDC transmission systems, according to the Energy Ministry. While there are no specific details regarding this initiative yet, the finding of this assessment supports the idea, as Sumber is shown to have a total of 133 gigawatts of solar PV technical potential, with generation potential of 260 terawatt hour per year. The potential is highest in the East Sumba. Region C, 60%, followed by Central Sumba, 21%, and Southwest Sumba Barat Daya, 10%, West Sumba, West Barat, Sumba Barat Virus, the last place at only 7% out of the 133 gigawatts. Conclusion, geospatial assessment of Indonesia's nationwide solar PV technical potential has been conducted using publicly sourced national and international data. The analysis finds that Indonesia's solar PV technical potential capacity ranges between 3,396 gigawatts up to the 19,835 gigawatts, depending on land use exclusion scenarios. In terms of generation potential, Indonesia can achieve 4,705 to 26,791 terawatt hour per year by taking up 4.34% to 24.43% of the total and mass. The result also shows that Indonesia's utility-scale solar PV potential is well above the current national official estimate, that is 207 gigawatts. The findings presented in this work could be used to support solar power development in the country, while at the same time meet future electricity demand and achieve renewable energy targets. Recommendation: to follow up this assessment, it is recommended that The government updates the nationwide solar technical potential figure as to reflect more detailed potentials for solar energy development in Indonesia. Current assessment shows Indonesia's solar potential is higher than current official estimate, and it has the potential to supply Indonesia's future energy demand too. Identification of prospective locations at provincial levels is performed together with the provincial government and the respective PLN's regional offices. Case studies such as for Bali and Sumba could be entry points to a more detailed planning. Assessments should include the current and projection of electricity supply and demand in the area. Grid study financing needs as well as related policies and incentives. 3. Further technical assessments can be conducted particularly to zoom in specific locations at cities, regencies, level, and even smaller, not only utility large-scale solar, but also for floating solar and rooftop solar. That's all.